All right. Okay. Well, again, happy Friday. Week 4 Friday. We are continuing our lecture on regular expressions and handling text. And on Wednesday, we left off. We talked about. We started introducing meta-characters, and so far we've only introduced a few. We've introduced the dot, which is a wildcard, stands for any character. And then we introduced the square brackets as a way to define ranges or character sets. Okay, so you can type in whatever characters you want inside the square brackets. You can set a range of values. And so we have square brackets to define character sets or character ranges. And then we also said there are negative character sets. So basically any character except these characters. Okay, and we left off there. We said the caret is used to define negative character sets. And so two carets inside square brackets or a caret followed by an escaped caret would indicate anything but the caret. Okay, characters inside the character set other than the dash, other than the caret in the first position indicate would be their kind of literal version of themselves. Okay, so now over here I escaped the character, the caret character, this one over here, but a lot of times it's actually not necessary because most meta characters inside a character set are assumed to be escaped. So that implies there is no need. You do not need to escape them using the double backslash. So for example, if we go back to this this vector of characters, pan, pen, pin, p0n, p.n, paun, and pwn3d, I can provide this character set where I have ae.iou. The dot here is not a wildcard. The dot here will be a literal dot. And so it will match the pen, the pin, the pen, and pin. It will not match p0n, but it will match the p.n because this dot is a literal dot here. Okay, and the other ones do not match because, again, character sets match only one character, just one of these characters. So here we have two characters in a row. This will not match. And the W is not one of ae.io or u. So the dot inside the character set now represents the literal dot character rather than the wildcard character. Okay, not all meta characters. Okay, the ones that do not become literal are the opening and closing square brackets because those those are expected to be related to the square bracket. The dash is used to define ranges, and the caret, if it's at the front by itself, would be have the meaning of making it a negative character set, but the caret somewhere else inside the character set will be a literal, and then the backslash also is used to escape characters there. Okay, character classes are kind of like shorthand versions of using character ranges. So certain character ranges are very kind of common, and so we have character classes, which are kind of like shorthand or shortcuts for defining character ranges. I would say you should memorize these three, okay? There are three things, the D, the W, and the S, okay? The D is any digit, so that's pretty easy. So all of these are backslash and the character. So, but again, in R, you have to double backslash, so that's a little bit of a weird thing, but most other regular expressions, it will be a single backslash. So backslash D, lowercase d, will be any digit, and then the capital D, so the character set is, you just have to remember three letters, D, W, and S, okay? D for digit, lowercase will be that character set, the capital is the negative we don't want. So /D is anything that's a digit, 0 through 9. Backslash capital D is anything but a digit. okay? Backslash little w is what we consider a word character. A word character is basically any letter, any number, and any underscore. So think about like what kind of characters would be allowed for like a username on some website, okay? So if you think about usernames for a website, you probably allowed letters, numbers, and underscores, okay? Some websites might allow other symbols in their username, but just kind of like a basic username type of thing, what characters are you allowed? These are word characters. So lowercase letters, capital letters, the digits 0 through 9, and the underscore. So the only one that kind of maybe surprises people is the underscore, but not a dash, not a space, okay? Capital W is a non-word character, so anything but those things. And then /s is any whitespace character. And these are all kind of a little bit hard to read. These are basically a space, a tab. There's like vertical tabs, like line, not line breaks. Oh wait, no. Yeah, line breaks are considered a white space character. But basically, you know, a whole bunch of kind of like, you know, if you have a whole bunch of spaces. So that's the S. So digits, words, and spaces, D, W, and S. So you should kind of try to have those committed to memory, but you know, you don't have to. You can always kind of look up regular expression cheat sheets, but I think there's three letters, simple enough, and then the lowercase is the thing, capital is not the thing. Okay, and you can think of these character classes as just shortcuts for these character ranges. Okay, so what is a white space? Okay, so white space, you have kind of your regular space. You have the form feed, the line feed, the carriage return, the tab, and the vertical tab. When you hit enter on a word processor, right? You're writing, you're in Microsoft Word or Pages or whatever it is. You're writing a thing. You finish a paragraph and you hit enter. What happens is your cursor moves to the next line at the front. Okay, that's technically two operations. It's a new line and it's a carriage return. It's kind of a holdover from the days of old-fashioned typewriter. So I don't know if you've seen, like in a movie, you have a typewriter and they go chugga 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 chugga, and then the paper. So I don't know if you've seen typewriters, or I don't know if you've seen an actual typewriter, but the thing that types the letters stays in one position, and then the way you get your letters to appear on the page is that you have the carriage, and every time you type it, it slightly moves a little bit over. And so in the movies, you'll hear, the thing is like, they'll go, and then you hit, and it'll go ding to indicate it's reached the end of the carriage. And so you hit enter, and that rotates the thing. It rotates the carriage so it goes to the next line, and then you see them go, and then they slide the carriage all the way over, right? So that's two separate operations. It's the new line is the rotation of the paper, so the paper moves up, and then sliding it over is the carriage return. And so technically, on a document, if you only do new line, and I don't think a lot of documents these support it, but if you typed into the middle of the page and you put in the letter A and you only hit enter, then the next line would be right in the middle of the page. And you can kind of keep typing letters straight down the middle. And then if you want it to end up on the left-hand side, you have to do the carriage return. So you'll often see, on Windows machines, if you reveal hidden characters, I don't know if you've ever revealed hidden characters in a text document or something, you'll see there's two things, new line and carriage return will show up. And that's what happens when you hit enter. It automatically does the new line and then the sliding of the carriage over. But anyway, I'll just say the /s is a thing. And I guess there's tabs and a vertical tab. I'm not quite sure what that is, but anyway, we could do this. This is P followed by a digit. Okay, and so this will just match the P0N. That's the only one that it will match. Everything else will be false. P/D, \D will be P followed by a non-digit, so that will match everything else. Okay, everything but the P0N. So these are kind of inverses of each other, right? Logical opposites there. Okay, P followed by a word character. what will this match? Or what will it not match? Word characters are letters, numbers, underscore. So it will match the PA, the PE, the PI, the P0. It will not match the P dot. It will match the PA and the PW. So we're going to get, oh, I'm sorry. I read this wrong. Backslash capital W. Sorry, capital W is a non-word character. My bad. Okay, so just the exact opposite of what I said. Okay, capital W is the non-word character, so it will not match the PA, won't match the PE. So basically, a no, 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 a no for the P0, a yes for the P dot, and a no for the other ones because those are all word characters. Okay, there are there's another way of kind of defining character classes, and these are known as POSIX classes. POSIX is, I guess, a class of operating system, basically Unix, Linux. They all kind of fall under POSIX systems. And so basically, you have these things, and you write this. Alnum is basically alphanumeric letters or digits. So not word characters. There's no underscores there. Alpha is any letter. Digit is any digit. Lower and upper, space, things like that. Punctuation symbol, printable characters, stuff like that. Okay. So you can say has any letter. This is going to be true. This is basically, does it contain any kind of letter? To use POSIX classes in R, you have to open with a double square bracket, double closing square bracket there. Okay, so any kind of digit, it will match only the one with the 0 or the 3 over here. All right, so those are character sets, character classes. All right, let's talk about anchors. Let me go ahead and give you your first view quiz answer. First view quiz answer is the letter C. C as in cat. C as in cat is your first view quiz answer for today. Okay, an anchor. Anchors specify positions. So they don't match characters, but they match the position. And so you can say, I'm looking for something, but only if it's at the start of the string. Or I'm looking for something only if it's at the end of the string. So I want to see if the thing ends with the letter S. I'm looking for things like plurals, or I'm looking for all words that start with a capital C, or something like that. Okay. We also have other anchors. One is the word boundary, okay? And a word boundary is basically the edge of a word. Edge of a word, and then capital B would be not a word boundary, so not at the edge of a word, okay? So here is, this is a vector of length 1, okay? Vector of length 1, a single thing. And what we're going to do is, and so I wrote, the quick brown fox jumps over the lazy dog, and that is all lowercase there. And here we're going to search for pattern THE, and we're going to replace all THEs with a dash. And so what this will do is we will get dash quick brown fox jumps over dash lazy dog. Okay. Here, the caret here indicates the start of the string. Okay, so remember, as far as anchors go, we have a caret for start or $sign for the end of the string. You can also use \A, and again in R you need a double backslash. Okay, capital A for start of the string, or \Z for end of the string. Yeah, again, caret or $sign also work. So this means the only at the start of the string. So it's only going to replace the at the beginning. This THE is not at the beginning of the string, not at the start of the string, so it does not match this pattern. Okay, here I've got double capital A, and this is the exact same thing as using the caret. So again, it matches that and not the other. Here we have the $sign, which means it will only match a THE if it's at the end of the string. Here it matches nothing, so nothing gets replaced with a dash. Okay. Okay, what about replacing the pattern DOG? Okay, we're going to replace DOG with a dash. And so this will become the quick round fox jumps over the lazy dash dash. Okay. This one, DOG dollar sign, says only match the DOG if it's at the end of the string. So it only matches this one at the very end. Okay. So it doesn't replace this DOG because this is not at the end of the string, but it will replace that one. So those are examples of a few anchors. This is /b is a word boundary and then any digit, okay, or any character. So word boundary and any character. And I haven't explained the parentheses and the vertical bar, but this basically means this pattern, or the vertical bar means an or. So or dot b. So this will replace start of a word boundary wildcard or word boundary or a wildcard followed by a word boundary. Okay, so what are word boundaries? So here the words are words, jump, jumping, umpire, pump, umpteenth, and lumps. Okay, and so what this will do is the edge of the words are the word boundaries. So it's going to replace the W, it replaces the S, it replaces the space because the space is preceded by a word boundary. Okay, it's also followed by a word boundary. So the space actually matches both of these. The J is preceded by a word boundary, and then the J, the P. So it's basically replacing everything at the edges of the words. Okay, edges of the words and a wild card. Okay, so those are at the edges of the words. Okay, so the word boundary itself. So this is a little bit of an odd concept. The word boundary itself does not occupy a character space. It is just kind of a location. So got no chalk. So So there is technically a word boundary here. There is, between the J and the U, there is a non-word boundary. Between the U and the M, there's a non-word boundary. Between the M and the P, there is a non-word boundary. And then after the P, there is a word boundary. Okay? So there are things, they don't occupy any like physical space, but they exist. Okay? They're like invisible lines, right? They're just borders, basically. They're borders between letters. Okay. Over here, I'm saying replace any wildcard, so any character, as long as it is between two non-word boundaries. Okay. So what letters will get replaced in, say, the word jump? Okay. The U is between two non-word boundaries. The M is between two non-word boundaries. Okay. So if you look at jump, it replaces the U and the M. In the word words, it replaces the O, R, and D, and so on and so forth. Okay. So we kind of get, complements of each other, sort of, between these things. Word boundaries and non-word boundaries. Okay. Okay. So what about this? Take a look at this, and here we have //b to indicate a word boundary. So at the start of a word, replace UMP. Okay. So what will get which words will get the UMP replaced with a dash? We will replace the UMP in umpire and umpteenth because those UMPs are preceded by a word boundary. Okay. The other ones are not. //big B, UMP, says replace UMP as long as it is not preceded by a word boundary. So it will replace the UMP in jump, jumping, pump, and lumps. Okay? It replaces the UMP in those things because those UMP is not preceded, are not preceded by a word boundary. Okay, here I have UMP followed by a word boundary, which means we need UMP at the end of a word. So we will replace the UMP in jump, the UMP in pump. I hope this is okay. If I'm going too fast, let me know if you need to kind of just pause and think about any of these patterns. Okay, all right, what about this one? UMP followed by not a word boundary. Which words will have their UMP replaced? Jumping, umpire, umpteenth, and lumps. Those are UMP followed by a non-word boundary. So we have jumping replaced umpire, umpteenth, and the UMP and lumps get replaced. Okay, I hope that makes sense there. Okay, all right, what's the difference between caret square bracket 0, 9, square bracket caret 0-9, and square bracket 0-9 caret? So this is one of those things where the caret, depending on its position, means different things. Okay, so the caret 0 through 9 is digit 0 through 9, and it has to be at the start of the string, right? It has to be digit at the start of the string. This caret inside here indicates that it is a negative character set, so anything but a digit, okay? Any character that is not a digit. And then here, this will be a character set with the digits or the literal caret. All right, now let's talk about quantifiers. Quantifiers allow us to kind of basically duplicate a character set without having to duplicate it. So I think earlier I had an example on Wednesday where I said, okay, what if you want 3 digits in a row? And I said, well, one way you can do this is you do square bracket 0-9, okay? And you can do 3 of those things, square bracket 0 through 9, square bracket 0 through 9, square bracket 0 through 9. Basically, we can do that with square bracket 0 through 9, and then we can quantify it by putting curly brace 3. I want 3 of those things, okay? You can also kind of quantify ranges. You could say 3, 4, or 5 by doing 3, 5 in curly braces, or 3, saying 3 or more, and then you can also do like comma 3 up to 3. We also have kind of more generic ones, or general ones. The star is 0 or more, the plus is 1 or more, and the question mark is 0 or 1. These things, and actually the 0 or 1 is greedy. It's going to try to match 1 if it can. All of these things are what we call greedy, and I will try to explain what it means to be greedy here. Okay, but greedy means try to find the biggest pattern that matches, and then non-greedy will be try to find the smallest pattern that matches here. Okay, so the text is a vector of length 1, and it is just one long character thing. It says words, space, or, I'll just say words or numbers, 9,876, and combos 1, 2, 3, like password underscore 1, 2, 3, 4. And so here we're going to say replace all white space with a dash, okay? So that's going to basically replace all the spaces with a dash, and we get this, right? Here we say replace anything but white space with a dash, okay? Capital S, anything but white space with a dash. So everything except the spaces get replaced with dashes, okay? Now we say replace the pattern of anything that is non-white space, 1 or more, with a dash. And this is greedy. And so what it will do is when it sees WORDS, these are all non-white space characters, and they are all kind of in a row. So the \S will match the non-white space, which is the W. It matches the O, it matches the R, it matches the D, it matches the S. It encounters a space character, so that it no longer matches. And this says 1 or more. So this entire thing matches the pattern of 1 or more non-white space character. It's going to replace all of WORDS with a single dash. It's going to do the same thing. It's going to replace OR because OR matches this pattern of one or more non-white space characters, and it's going to replace that with a dash. Same thing with the entire NUMBERS. All of that matches this. Same with 9876. And so what we're going to end up getting is we're going to just get a single dash for basically every word here. Okay. What's going to be the difference between this one and this one? This one says anything that's non-white space, one or more. And this says anything that's a word character. Word character being the letters A through Z, digits 0 through 9, and the underscore character. So are these going to be the same? Is there going to be a difference? What's the difference? Looking at this. There's one character on there that is not a word character and is a non-white space character. The comma, okay? So basically we're going to get the same thing except the 9 gets replaced with the dash. The comma is preserved. The comma is not replaced with the dash. And the 876 gets replaced with the dash. So we end up with a comma. That's the only difference between these two things. This says replace any digit with a dash. So the 9 will get replaced, the 876 will get replaced, the 1, 2, 3, and the 1, 2, 3, 4 get replaced with dashes. So we get this. Okay, so all digits get replaced with a dash. Replace all non-digits with a dash, so we get kind of the opposite here. All the spaces are considered non-digits as well, so everything gets replaced with a dash except for the digits. This says replace one or more digits with a dash. So the 9 will get replaced with a dash. The 876 get replaced with one dash. The 1, 2, 3 gets replaced with one dash, and the 1, 2, 3, 4 get replaced with a single dash. Okay, and this is kind of the opposite. Replace any one or more non-digits. Okay, and so this entire thing here, from I can't highlight. How do I? There we go. Okay, so everything from the W to this space matches this pattern of non-digit one or more sequential non-digits. And so that entire thing will get replaced with a dash. And so we get dash 9, the comma gets replaced with the dash, and basically from, I'm having trouble, I can't, the computer won't let me highlight. But basically from the space after the 6 up to the S before combos gets replaced with a single dash. Okay, this actually almost looks like a phone number now, but yeah. Okay, the question mark. The question mark says 0 or 1 with a preference for 1 if it can match 1. Okay, so this says replace 0 or 1 digits with a dash. 0 or 1 digits with a dash. Okay, so now we're going to get something a little bit wild here. Okay, and basically, okay, it says there's no digit, there's 0 digits, 0 digits before the T, we're going to replace it with a dash. There's 0 digits between the T and the H, okay, that gets replaced with a dash, okay? And so basically everything, and the concept of a 0 is a very kind of a weird thing. And generally, you would not do something like this, where you have a single thing with a 0. Generally, it's kind of like in the middle of a pattern. You generally would have something like, when somebody specifies their phone number and they write it down, sometimes they will put parentheses around the area code and sometimes they won't, right? And so you might want to say something like parentheses, and we will accept 0 or 1 parentheses, followed by 3 digits, followed by 0 or 1 closing parentheses. And that's when you would use the comma. Here I have a digit followed by a question mark, and so now the entire pattern could be 0 or 1. So you get kind of these weird things where you end up like there's zero digits between A and R, 0 digits after the R, and then each of these things, we have a 0 digits before the 1, and then it prefers to replace each of these with 1. with a preference for 1. So the 1996 gets replaced, and so you end up getting something like this. Okay. So I don't recommend the question mark in a pattern all by itself, generally part of a larger pattern. Here this says replace exactly 3 adjacent digits, and it reads left to right. So it's going to read, and it goes 199. That is 3 adjacent digits, and it replaces that with a dash. Okay, and then we have a 6 left over, and no more digits after that. So it leaves the 6. Okay, the 310 gets matched exactly. The 123 gets matched exactly. The 1234, again, it reads left to right, so it matches the 123 and goes, I found a match to this thing. I'm going to replace it with a dash, and it leaves kind of a 4 hanging over there. Whereas over here, I can just say replace between 2 to 4 characters, and this will try to get as many as it can. So if it can get 4, it gets 4, and so it replaces 1996 with a single dash, rather than trying to say matching 19 with a dash and then 96 with a dash. It matches 1996, replaces with a single dash. 310 is between 2 and 4 characters. 123 is between 2 and 4 characters. 1234 is between 2 and 4 characters. But the single digit 5 does not match between 2 and 4 adjacent digits, so that gets left with a 5 there. Okay, so that's how the quantifiers work. Is that I hope that makes sense? Let me go ahead and give you your next view quiz answer, which is the letter B. B as in bear. B as in bear is your second view quiz answer. Okay, by default, quantifiers are greedy, okay? And greedy means it will try to match the longest possible match that still matches the pattern, okay? If you add a question mark to the quantifier, okay, it will make it ungreedy or lazy, and it will return the shortest match that matches the pattern. Okay, so here is a vector of length 1, and the string there, character string, is Peter Piper picked a peck of pickled peppers, right? And so we're going to try to match the pattern capital P wildcard star, okay, which means basically any character and 0 or more of them, followed by an R. So this, what will this match? It is greedy, okay? And here's a question. Does the wildcard match spaces? Yes, okay? The wildcard matches spaces. So it is going to search for a capital P to capital P to R, and what it will match is it matches the capital P in Peter all the way to the R in peppers. Okay, and when we say extract this, it basically gets almost everything except for the S. So it matches this entire thing. Peter Piper picked a peck of pickled pepper. Okay, and it matches from the capital P all the way to the R. This dot star matches everything there. If I put in a question mark here, question mark says match only the smallest thing that matches, which will be from the capital P here to this R in Peter, and that will be it. Okay, and string extract says only the first match. So here we just get Peter. Okay, if I did string extract all, we would get Peter and Piper. Okay, but here, this is the ungreedy, and it says find the smallest match that matches capital P followed by 0 or more wildcard characters, but make it as short as possible that matches that ends with an R, and the shortest match will be this Peter. Okay. Okay. All right. Here's string extract all. So we have the ungreedy match, and so doing capital here we get Peter and Piper. Okay, and then all right, what will this match? I have capital P or lowercase p and a character set, followed by 0 or more wildcard made ungreedy with the question mark, ending with an R. And it reads left to right. So we're going to match Peter, we're going to match Piper, And then, starting with this P, we're going to go from picked a peck of pickled pepper. Peter, Piper, and then starting from this P to this R, we get a match there. Okay, it reads left to right. That's kind of the thing. Because you might be like, oh, try to find the smallest thing, and you get, oh, I can find the PER. But that's not how the regular expression works. Okay, it says, all right, we're reading left to right, so we go capital P. Okay, that matches dot star, keep going. R. Okay, that's the end. Here's another capital P. That matches R. Okay. P, match, R, and it ends there, okay? We can, continuing on here, we can define groups, okay? Parentheses will group together parts of a regular expression, and when you use parentheses, these also create something called a capture group, which kind of pulls things out. So, capturing group kind of matches part of the pattern, and you can reference those things by group number. If you put in a question mark colon after the opening parentheses, this becomes a non-capture group, all right? And so this A, B, C, D, E, F, G, H, I, but we've kind of grouped this together. We have a group A, B, C called capture group 1. This matches the exact pattern. These are all just literal characters. D, E, F will be in capture group 2, and GHI is our capture group, but it is not captured. It is still part of the regular expression, and it still has to match the GHI, but it is, we would say, is not captured, meaning, when you do a match, this portion of the pattern doesn't get returned, but it still searches for it, okay? It's a little bit of a weird concept, okay? This idea of capturing just says, hey, match this thing. It still has to match the pattern, but then we're like, sometimes we want to extract pieces out, okay? So let's just kind of look at a few things. So again, parentheses kind of groups together portions of your regular expression, and it creates a capture group. So we have to, in this case, we have to match the pattern A, B, C, D, and we establish a capture group for BC. Generally, you mix capture groups with wildcards to kind of allow for different things. You wouldn't really use a capture group for a literal character match. Here this says we have to match ABC, but we're not capturing that group. Here we have capture group ABC, part of the pattern DEF, and a capture group GHI. The grouping also allows you to kind of put in OR, and so we can match MRS or MS or MR, okay? And then 1 and 2, /1, /2 reference these capture groups. And it can kind of be used in conjunction with something like replace, okay? The vertical line is kind of like OR in logical expressions. And we saw one example of the vertical group and the capture group when we were looking at like this word boundary followed by a dot, or a dot followed by a word boundary. So here, I'm saying I'm using this with string match, and we're going to search for this pattern B, C, D, E, F, G, H, I. G, H, I is not part of the capture group. And so here it will tell you what part of this text matched the pattern B, C, D, E, F, G, H, I. And then it extracts out the portions of the pattern that match the B, C, and the D, E, F. Those get extracted. Here I have A, B, C, D, E, F, G, H, capital I, and it says, okay, I don't find a match anymore, right? No more match because it doesn't find this GHI here. Okay, here I got this text, Mr.Smith, comma, Mrs.Lee, comma, Ms.Garcia. And here we are going to search for this pattern MRS or MS or MR, okay? And again, regular expressions read left to right, and it gives preference to the pattern in left to right. So here we match the MR in MR dot, the Mr. Smith, the MRS in Ms. Lee and the MS in Ms. Garcia. And these are all part of a capture group, so they get kind of extracted here. If I specify my pattern in this order, the MR followed by the MRS followed by the MS, as it reads this, it's going to match the MR in Mr. Smith, and it matches the MR in Ms. Lee, so Mrs. Lee. So it gets the MR, and again, it reads left to right, so it's going to say, oh, I found a match here, we're done, okay? And then it moves on, and it finds a match with MS, Ms. Garcia there. Here is kind of another example where here I could just say M. This is, I don't have the vertical bars to say or, but I could say M followed by R question mark, meaning one or more R's, 0 or 1 R's, sorry, 0 or 1 R's, or 0 or 1 S's. So we will get MR, we will get MRS, and we will get MS. What is one thing this will match that this would not match? This would also match just a capital M all by itself, okay? Because it would be M followed by 0 R's and 0 S's, and that would also still be a match, okay? Here, so this is where the capture groups actually get useful, okay? So here I have Mr. Smith, Mrs. Lee, Ms. Garcia, and Andy Hope here, and I've got this thing, MRS or MS or MR, followed by a literal dot, right? This is a literal dot because they're escaped with a backslash, followed by a space, followed by one or more word characters, and the word characters are in a capture group. So this will, when I do a string match all, it's going to find matches of this entire pattern, and it will extract out the capture groups. So it says, okay, mr.space_Smith matches this pattern. And then the part that's in this parentheses gets extracted as a capture group. And the part that matches this parentheses, which is the Smith, gets extracted, okay? And here we get, this matches Ms. Lee, Ms. Garcia match, and it extracts out the portion of this pattern that match. And it matches, and it extracts out this portion, which would be their surname that also matches. Andy Hope does not match because Andy Hope is not preceded by one of these, this pattern of MRS, MS, or MR. Okay. So that kind of makes sense as far as how these capture groups are working. And so these kind of get useful, right? Now we can say, all right, now we have a pattern to kind of search for one of these titles and basically their name here, their surname, and it will extract it out. And so now we have a column corresponding to, whichever title it matched, and a column corresponding to the surname that matches there, okay? Here, I put in a question colon. So basically says, you know what? We just, this is a capture group, so we want to kind of group these things together, and we want the MRS or the MS or the MR, but I'm not actually interested in capturing it. I don't actually care about the title. I just really want to get this last name. So it says, okay, we matched Mr. Smith, and here the only capture group that we're saving is Smith. The only capture group that we're saving is Lee. The only capture group that we're saving here is Garcia. So these are, we have a non-capture group. This is still a grouped part that it's searching for. So it doesn't match Andy Hope. So even though we're not capturing it, it does have to match one of the things in this group, okay? So Andy Hope doesn't match, and we extract out only the portion that is in the capture group in the string match. All right, here is, we can use these references. So when you use capture groups, they get referenced with /1 and /2, okay? So this says word character space word character, one or more word characters, and an optional comma. So here I got George Washington, comma, John Adams, comma, Thomas Jefferson, end of the string. what would this match? We're going to match everything that matches this pattern of one or more word characters, space, one or more word characters, and an optional comma. So we will get George Washington, comma, and we extract out George and Washington. We match John Adams, comma, and we extract out John and Adams. We extract out Thomas Jefferson, end of string, and we match Thomas and Jefferson. Then, if I wanted to, I can replace this pattern, okay, of word characters, space, word characters, comma, and I can say, take, anytime you match that pattern, replace it with a back reference to the second capture group, Washington, followed by a comma space, followed by the first capture group, which would be the first name, followed by a semicolon. So what this will do is it will take this text, George Washington, comma, John Adams, comma, Thomas Jefferson, end of string, and it will replace it with Washington, comma, George, semicolon, Adams, comma, John, semicolon, Jefferson, comma, Thomas, semicolon. Okay, so this would be kind of like, I don't know, if you wanted to take this thing and kind of turn it into like last name, first name kind of business and separate it out like that. This is kind of neat, I think, that we've accomplished this with a single regular expression and a single command of referencing this pattern, and because we've used capture groups, we can kind of refer to them by number and replace the text that way. All right. Can we understand what this thing says? So as we start building regular expressions, they just start getting more and more complicated. It's like having these Lego pieces, and you can just start building these. All right, what does this say? This says we want a word boundary followed by one or more word characters, which is a capture group, followed by one or more spaces, a back reference to that first capture group, followed by a word boundary. Okay, so what is that? Well, this says, because I'm saying a back reference to this capture group, this is going to search for any words that are repeated. Okay, so I have the quick brown fox jumps over the lazy dog, and it says, oh, you have a pattern. You have this thing where you have the THE matches followed by a space matched by the same word here. Okay, it's a back reference back to this thing. So it's going to search for any time where a word just gets kind of repeated. So it matches the. All right. What about this regular expression? Okay, so I mean, is this fun here? Okay, here we are saying match a literal, all right, and I've tried to explain out what's happening here. Match a literal opening parentheses, okay, and it is optional because I put the question mark. Question mark means 0 or 1. Followed by, okay, a group. So now we have a regular parentheses, a capture group consisting of a digit between 2 and 9. So if you think about phone numbers in the United States, okay, area codes have to start with a digit between 2 and 9. You will not have an area code that starts with a 0. You will not have an area code that starts with a 1. Okay, there's no area code that starts with 1. Same thing with the your first kind of portion of the phone number, the area code, and then 3 and then 4. That 3 will start with 2 through 9. Nobody's phone number starts with a 0 or 1. Okay, so we have a digit followed by a digit between 2 and 9 followed by exactly 2 digits. Okay, and that forms a capture group followed by a literal parentheses that is optional. Okay, and then that could be followed by either a dash, a space, or a literal dot, and that is optional. And then we will follow this by another capture group starting with 2 through 9. 2 digits followed by a dash, space, or dot, which is optional, followed by 4 digits. Okay, and that forms a capture group. Okay, So here I've got a text vector of several things, 1, 2, 3, 4, 5, 6, and we're going to just say extract out the match, right? So we got Apple, we got 1-800 this, that, 310 space, 310 dot with dots, no spaces in between these things, and this person decided to list off 2 phone numbers in the field, and this person puts in 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, right? This one is not a valid phone number because it starts with a 1. We're going to use this phone pattern. What do we extract? We get no match for Apple. We get 800 this, we get 310.209, we get that match. This matches 310.209. This also matches, it matches only the first one for work, and that's what string extract does, and then this one does not match. If I do string extract all, okay, this allows, so for in this instance, this person entered 2 phone numbers into the single text field, and string extract all will match all things. And so instead of getting a vector of the same length as the input text, we are going to get a list with the same length as the input text. And each element of the list is a vector that could contain 1 or more values. We had no match for Apple, so we get a length 0 character vector. Okay, everything else pulls out the same thing with the exception of the work home thing. It pulls out both of those matches. Okay, and then no match for the 1, 2, 3, and so we get a character 0 here. Is that okay? The difference between string extract, which only matches the first, and string extract all, which is going to return a list. Oh, and I'm going over. Okay, and then so one last thing. So we can say, all right, take a look, and let's just look at those capture groups. And so we found, just doing a string match, it returns kind of this matrix with 1 row for every kind of entry in here. And then it extracts out the capture groups, which will be the area codes and then the phone number portion. And if you did string match all, you get the same kind of thing, except the one where the person entered 2 phone numbers, we get a list entry with kind of 2 rows there. Okay, and then and so anyway, we can kind of work through this, and here I'm going to kind of use string match all, extract all of those things, and then kind of combine them back into a single matrix. And then if you hate the fact that these things are formatted differently, we could then go through and we can try to do some cleaning up, right? And so here I'm saying, here's a capture group, here's the optional dot space or dash, and then followed by another capture group, and then I want to replace that with a number dash number, right? So all of these things, even though we've got a dots and we got no spaces here, and I've got a space, and here I have a dash, I can go through and I can do a cleanup using the string replace and referencing the capture groups. Okay, so this thing, even though it has a dot here, gets replaced with a dash. This thing had nothing separating it, and it inserts the dash there. This has a space, and it replaces it with a dash. So here we're kind of using the patterns and the capture groups to get through that. Okay, how many view quizzes have I given you? 2. Okay, last view quiz answer is the letter E. E as in elephant. E as in elephant. And you'll just have to kind of look at these last couple slides on your own on look-arounds. Hopefully the examples that are provided will help you make sense of the look-arounds. But now you have the tools to kind of work through the very last section on the homework, the managers column, and extracting information out there. All right, have a great weekend, and we will see you Monday.